let me give you a conjecture. The conjecture which I have in mind is that the sum of the first n positive numbers, and this is an interesting formula, it's the last number multiplied by one more than the last number divided by 2. Well, let's just see if that's true at all for a while. Look at 1 plus, well, if n is 1, the right-hand side here, the left-hand side here is 1, and 1 times 2 divided by 2 is also 1. If n is 2, the sum of the first two numbers here is what? 1 plus 2 is 3. On the other hand, 2 times 3 divided by 2 is also 3. So at least our conjecture is true for n equals 1 and n equals 2. What does mathematical induction say? Let's take a look again now. You see, we showed that the conjecture was true for n equals 1. And for good measure, we also showed that it was true for n equals 2. So we can check this off. We've done that. Now what do? We assume the conjecture is true for n equals k. That means what? Well, just replace n by k. We're assuming that this is true. From the truth of this, what must we do next? Well, what we must do next is investigate what happens if you add what? Not k numbers, but k plus 1. See, in other words, what happens when you replace n by k plus 1. Now watch how we do this. The same thing that we did in theory before. We say, look, we already know how to handle this amount. We're told that that's going to be k times k plus 1 over 2. So let's rewrite this in this way. Now we can replace the bracketed expression by k times k plus 1 over 2. We add on, of course, k plus 1 because that's the last term that's over here. Now we factor out k plus 1 from this factor here. That leaves us with what? K over 2 plus 1. And this in turn says what? That the sum of the first k plus 1 numbers is k plus 1 times k plus 2 over 2. And notice that that's exactly what the conjecture should say when n equals k plus 1. Namely, what? The sum of the first n numbers, no matter how many you have, is what? The last number times one more than the last number divided by 2. The sum of the first k plus 1 numbers is what? It's k plus 1, the last one, times k plus 2, which is one more than the last one, divided by 2. And now what we've done is we have verified the second part of our mathematical induction setup. Namely, if we go back to our basic definition over here, we had to show what? Prove that the truth for n equals k implies the truth for n equals k plus 1, which is exactly what we did. And while you're thinking about that, let's take a break for a few more asides, which I think may cement down this idea a little bit more strongly. I mentioned before that induction is something that one uses when one already has a suspicion as to what the right answer is. I don't know how this grabs you, but my own particular feeling is that you do not look at the sum of the first n numbers and say, aha, it's the last one times one more than the last one divided by 2. You see, that's the nice thing about textbook problems. When they give you a problem on induction and they say, prove this conjecture, notice that they've already given you a tremendous hint. Namely, they've told you what the conjecture is. You see, in the textbook of real life, one usually has to find out what the conjecture is for oneself.